Hello everyone, welcome to this video for 6th grade, lesson 2. Get started. So, number 1. Logan and Emma are candidates for the school election. For every 6 student voters, 2 of them voted for Logan. What is the possible number of students who voted for Logan and Emma? So how we'd start this problem would be, since it's for every 6 students, 2 of them voted for Logan, we can assume that Emma is the 6 every student voters, because as the ratio says, it's 6-2, and a 2 is for Logan, and we don't really know if it's for Emma, but if we look here, so we can say that right here, this is Emma. And we have to flip this for the sake of the ratio that the question wants. So 2 to 6. And we actually have to reduce these to this simplest form. So we'll divide it by 2. We'll go over 2 over 2. So 1, 2, 3 ratio for Logan and Emma. Now, using this, get the answer choices. All of them have a commonality of 120. So we'll multiply this by 120 and multiply Emma's by 120. So we get 120 to 360. And we want to transfer this. So our answer is B. Number 2. Mia has 36 forks, 24 knives in her silverware jar. What is the ratio of knives to forks in the jar? So, okay. We have 24 knives and to 36 forks. So if you want to know the greatest common factor to reduce these the fastest way, and keep in mind, you don't have to use this. You can use mental math, but some teachers might make you do this. I know they did for me. So GCF, we have one of 24 and 36. Now we know the common factors for these are 1, 2, 3, 4, 6, not 8, because 8 is only here for 27. And there is just 12. Yeah, and our greatest common factor is 12. So I'll divide these by 12 to get 2 to the ratio of 3. And that is B in this equation. All right. B. There are 50 empty seats on the bus and 20 passengers. What is the ratio of passengers to empty seats? So on here, we can say that, this is 20 passengers to 50. And we'll use the GCF method. Keep in mind, you actually don't have to use this. I still don't know why my teacher made me do this method in school. So we got 1, 2, we skip 4 and 3 and 4. Then we have 8, 7, 8, 9, 10. No 25. And that's actually it. So greatest common factor is 10. So I'll divide this by 10. So we'll have 2 to 5, which is A in this problem. Number 4, the perimeters of two squares are 6 inches and 20 inches. What is the ratio of lengths of their sides? So it's two squares of 16, 20. What is the ratio of lengths and their sides? So we'll actually draw these two out. So we have our square number 1. It's 16, which is our perimeter, and we have square number 2, which is 20. All right, so we can actually put this in a ratio. But in order to get 16 as our perimeter, we need to have 4, 4, 4, 4. And for 20, we need to have 5, 5, 5, and 5. Since it wants the lengths of their sides, we can see here that it is like this, as such. So this might sound a little bit tricky, but when it says of their sides, so it's of their sides. I'm assuming it's asking for the total length of the square of perimeter of 16 and the perimeter of 20. So when we're here, we will just write lengths of their sides. So we have here. We'll have for lengths, we'll have 5 because from here we can show, actually no, it's so yeah, we'll have 4 here. We'll have 4 sides, and so their sides, we'll just go 4 plus 5. We'll get yet again 9. And ratio of the lengths of their sides. So it wants the ratio of the lengths of their sides, which shows that our ratios yet again 4 to 9. So answer is B. Number 20. I know not number 20. Number 5. For every 6 unemployed workers, there are 2 unemployed. What is a possible number of employed and unemployed workers? So for our 6 unemployed to 2 unemployed, we'll put says wants the possible employed. Okay, so wow, this question is gonna because it says it's for every 6 unemployed workers, there's 2 unemployed workers. So I think what the question wants is actually for 2 employed. For every 6 unemployed workers, there are 2 employed workers. So we'll scratch the un part, and we'll say, so for every 6 unemployed, we have 2 employed. And what's the possible number? And here everything's in a 300 to 400 to 100 to 100. And I'm going to actually use the 100s because they occur the most. And it's like from complete random that I just pulled out 100. So multiply this by 100. Also multiply this by 100. So we'll have 200 to 600. No, it actually sounds weird. Maybe we can like reduce this. Oh yeah, we can. So here, I accidentally multiplied by 100 too many times. So we'll divide this by. Actually no. This is better. Yeah, we'll divide by 2. We'll also divide this by 2, and our ratio here will be 100 to 300. And that is C. Number 6. There are 12 Americans, 8 Italians, and 10 Germans in an international science team competition. What is the ratio of Italians to Americans? So there's 8 Italians and 12 Americans. So our ratio would immediately be 8 to 12. Okay, now we'll use the GCF method. 1, 2, and 4. That seems to be about it. So we'll use 4 over 4 over 4, 2, 2, 3. That is C.